In this demonstration, I'm going to show you how to detect and respond to critical events in real time without having to look at data in 20 different systems like you probably have to do now. Now, the XMPRO Event Intelligence platform consists of three main components, and the first one are the data streams that you see on the left, which is really aimed at connecting and bringing information from those 20 different systems. In the middle, we help you visualize and find those key events that you are looking for that you want to respond to. And the last part is how do you respond to those through recommended actions or having actions and workflows in other systems. So let me jump in, and we're going to start with what you see on the left, the data streams, and how do we connect all of this information coming from multiple data sources. Then we'll move into how do we set up these visualizations and the notifications that go with them, because you don't look at a dashboard 24/7, to be honest. You need notifications around specific events that are starting to happen. And then how do you respond to those with recommended actions? So let's jump into the data streams. So this is the central console where you can access all the different modules within XMPRO. So the app designer, the data stream, process designer. What you'll see, I have different instances running, production, simulation, demonstration instances. So I'll actually jump into the data stream designer itself, and this is where we set up those integrations where we can connect to those 20 different systems, get data from them, and the data could be real-time data from machines, from websites, from web services, from other business applications, and streaming data that could come from multiple sources. You can also then decide how to apply some analytics to it and what actions you want to drive from it. You can organize it into different areas. So in this instance, different categories, so based on your business structure or business organization, supply chain, safety. And in this instance, I'm going to look at equipment. And I'm also just going to show you two different examples. The one is a very basic, simple example for condition monitoring. And in the second one, we're adding some smarts in terms of being able to predict when certain equipment is going to fail. So let me start with the simple version. And in this one, we are just going to connect to one data source. In this instance, the data source is through OPC UA, which is a protocol based, and we're getting temperature and vibration readings for this pump. We're getting the make and model of the pump from a different database system. So this is data in motion. This is typically data at rest. So this is fast moving, fast changing. It could be thousands of records per second. It could be a couple of records every 5 minutes. It really depends on the use case and the application that you set up. So in this instance, we're getting the vibration and temperature data. We contextualize it with a make and model because we want to set the rule for the vibration checking for that specific model. And then we want to start a spares and work order request inside a external system like SAP or something. In this instance, we're kicking off a workflow inside XMPRO, and then we would like to SMS someone that something is happening. So a very simple structure in terms of being able to monitor real time. Now, I can apply this model for one or tens or hundreds or even thousands of pumps that run the same. So if I've got 200 or 300 slurry pumps, I can run the same model as one instance across all of them, and it will continuously look across all of them for these conditions. I'm trying to find these events. I'm trying to find when the vibration is above a certain level. And what we have from the ability to bring data in is something we call listeners. So these are all agents, our listening agents, and this is just a subset, but there's a broad range of listening agents. So we can listen from, again, a broad range. And if we don't have it, it's pretty easy for us to get it into our library that you see here. Just different systems where I can get real-time data streaming in, or where I can actually poll. So if it's not a data that can a data source that can push it to me, I can also pull it in. Context data, this is where I add make, model, maintenance records, other information that I may have, which may sit in something like Maximo or SAP or any one of those systems. Again, this is just a subset of some of the systems where we can get context from. so that we know which pump this temperature value belongs to, because the sensor typically just sends the sensor ID or something like that along. In terms of transformations, this is how we manipulate the data. So what do we want to do with it? How can we aggregate? How can we filter? How can we join? How can we pass through? How can we set up thresholds, the ones that you see there? All of these ability to transform the data in one shape or form. In the next example, I'll show you a little bit around the machine learning capability, where we just bring in some machine learning, but in this instance we don't use it, but we have standard machine learning capability built in. So multi-class classification, regression, so this is typically will it fail, what is remaining useful life, but you can bring in things like Jupyter Notebooks. If you already have models in Watson or Azure or those, you can actually bring them in as well. Functions, these are things like fast Fourier transformations or functions that you want to perform when you manipulate things like Python scripts or R scripts or certain signal filters that you want to do. So these are more function based, not so much transforming the data, but just applying the data and getting an answer out of something. And then lastly, and almost most importantly, is what are the actions that you want to do, because we're not trying to do this just so that we can detect them. We actually want to respond to them. So it's around event response and then optimizing that response. So these are the different action agents. And again, a subset. So I may, for example, want to send out an email. As you can see, we've got an SMS over here. I may want to update a Ethereum smart contract. I may want to send it to a chatbot. I may want to broad range again, and then there are generic interfaces like REST APIs and other standard protocols and formats that you can send things through. So again, just a subset, and you can also send it into XMPRO, into the app designer, into the application itself, where we run rules and recommendations and have a user interface for all of this data that we've put together. Again, a very simple example, and if I double click on this, what it'll show you is just how I set up this, the configuration for this. I'll show you another example in a minute of a Pi server or OSI soft server, where the configuration very similar, it just has different fields and information. You can see this is what it's passing me in my OPC UA link that it's sending. So this is the topic that it sends it to, and I just subscribe to this endpoint, and I'm getting streaming data into the application itself. So if I show a live view of that information, I can actually see some of that data coming in, and this is a unit that sits in our Dallas office, so I can get temperature and vibration readings, and just to show you that this is actually connecting from live data. In this instance, this is just one, but it could be reading from multiple devices, and for those I would then get the individual ones. This is just a live data view. This is not the dashboard that we show to the end customer. This is really just to see that the data that comes out the thing is the data that we are looking for. So very briefly, this is how we connect up those 20 data sources. If I go back and if we look at, so just go back to the pumps, and just to very quickly show a more advanced or expanded version. It's still a predictive, still a centrifugal pump, still getting temperature vibration, but now we're getting pressure and flow from OSI soft. In this instance, I still have access to all the same connectors, so I can drag them on. I can have multiple inputs, and again, this is how you connect up the 20 different data sources. In this instance, it's reading from SAP, and you can see from a configuration point of view, this is slightly different to the one that I showed before, but I can and this is looking at the OSI soft asset framework, for example, and brings back the elements as well as the components, and I can choose some of the others that I may want. I may want the impeller size or something like that. So this is how I set that up. In this instance, it's the same. We're still checking for thresholds, but I'm also calling a predictive model, in this instance an Azure based model, to predict the likelihood of failure. Is this thing likely to fail, yes or no? If it is, I want to run a second predictive predictive model, so I can chain models together. And in this instance, what is the remaining useful life? How much time do I have before this pump fails? And again, I'm sending this into my XMPRO app designer, which I'll show you in a minute how we now get this data into a user interface. But this is a key aspect and a really important aspect of being able to build real-time event response solutions, is being able to connect to multiple data sources, get a high volume of data flowing fast, and being able to find the exceptions and find the key events that you are looking for, and bring the data from big data to smart data to the action that you actually want to do. Just to try and build a dashboard that connects to all of these sources, it doesn't have the capability to help you find the key things. It can show you the tank level. It doesn't tell you whether the tank level is actually a problem. And I'll get back to the tank level in a minute. So this is the data designer. So if I go back to so this is the data stream designer, and this is where we connect all of these data. What we now want to do is create some user interface to just show it to someone so that they can see what's happening. They want to see certain of the areas, and then have some recommendations around what to do. Now, we don't call these dashboards. For us, they are event boards. And the reason is the purpose is slightly different. So if I quickly go in and show you an example of such a event board, this is connected to some data flowing at the back. And here's the event board. So what this tells me is there are certain key events starting to happen, or things are already happening. There's an event right now, or there's a likely event starting to happen. It doesn't show me the tank level. This differs from an HMI view or a control system view or something like that, where you can see the speeds and feeds and the motor amps and all those information, which in actual fact you don't really care too much about until you know it's wrong. So I need to know whether a high tank level is a good thing or a bad thing. Just having an indicator telling me this is sitting at the top doesn't really tell me if this is a good event or a bad event, and is it something I should be concerned about or not. And that's the whole purpose of what we call event boards. So we put these event boards together, and there's different ways of displaying the information. So this is one way. So in this instance, you can see there's a problem with this pump, and we'll get into the recommendation that was fired for this in a minute. But I just want to show you a slightly different example of, and if I go back to this, if I look at the conveyors on that plant itself, I can also have a different view where for all the different conveyors I can see certain properties, and I can have a rule behind the property to say, well, in terms of this instance, the amps on the motors for this conveyor, is this a challenge? And there might be, because there's certain real-time information, and again I can show you whether this is good or bad and what does it mean, which is more important than just having a tonnage, is to say, is this tonnage good or is it bad? Is the motor amps good or is it bad? Is something starting to happen, and do I need to respond to it? So again, just going back to this plant over here, and I could actually have just gone through into that, but I will let's look at the motor example. So in this instance, I can see the discharge pressures, current flow rates. I can see and over a period of time, so I can see certain information around that. Now you'll recall a whole bunch of dots on here, and they tell me this is a good event or a bad event, the way that you decide in terms of the coloring is that red events are needs immediate action, yellow events may be longer. This is really completely up to you to configure when you design these apps, and I'll show you in a minute how we put these together. But before I do that, I just want to show you what a recommendation is. So here's an example of a pump that we drill down to, and I can either access it from here, or let me go into the pump itself. I look at some of the information, I can see what's happening, and now I click into the recommendation. Now the recommendation is how we act on the event, and what you'll see is this is the data that fired that instance. So you can see in the past it's been resolved. This is this is the real-time data that fired. This is the I can put in a recommendation here to see to say please check something or do something, or make a suggestion to the maintenance planner, or in terms of what they should put on the work order, to say this is a test impeller. And I'm not going to this is a test impeller. Can't spell. Please discuss with manufacturer. So I can now, so the reliability engineer or some subject matter expert can actually look at, I'm not going to type all of it out, so you can talk to the manufacturer. I can either do this automated, or what we find a lot of organizations want, they want to create a work request number. So in the SAP or Oracle or Maximo system, they would go and create a work request number, and we would then poll that system to see when a work order is created by the maintenance planner. This could be done fully automated as well. So right at the end here, you could actually just create the work order inside SAP if you wanted to. But in this example, we are doing that. You can also put together different instructions, and the way that you set this up, which is actually kind of more important in a way, is setting up these rules for these recommendations. And I'm just going to go into manage recommendations. This is the area where I can manage a lot of all of these rules that I set up around specific events that I want to fire, and these are the ones that you saw the red dot and you saw the yellow dot appear. So for that red threshold, this is the rule that and you can see this is a very simple rule that we've got with the data that's coming out of our test system. But I can just create that red threshold, or it could be a low suction pressure, or in this instance distance pressure high threshold, or in this very simply named red here. And then the information that flows in this data stream that you see here, where it hits this is the data that actually flows out here. So I've got access to all of these different fields that I can now put a rule against, and when this rule is true, it will put that dot on there for me, or whatever other indicator. The dot is just one that we find is pretty universal, but you could put any indicator or any notification that goes with that. So I can either have a value, or it could be something, another variable that comes in that. So if the flow rate is less or equal to the power, this one doesn't make sense, but it illustrates the concept of what we are doing here. And I now have a rule, and when the data flows through this data flow, it finds a true condition, it would then give me the notification. It would put the dot on the equipment for me, and also give me this recommendation which I saw earlier, that I can now either create work requests, have standard procedures around how to fix this, and use this as a recommended action. Now the benefit of this is this can be done by someone who's been there like 45 years. You capture their knowledge around what would you do when these conditions exist, what would your recommended actions be, and through that you also build up in your knowledge base the best actions under certain circumstances. The other benefit is that person who knows how to operate and use this doesn't always have to sit in the control room. They can sit in the office, in the boardroom. They could even sit in the bedroom and be able to monitor, look at things, and then make decisions on what are the best next actions that you could do. Now there's a lot more to this, but one last thing I just want to show you is how do you set up these. Now this is running on live data, so I'm just going to use a slightly different system, but we'll still have the same view. This is how I manage and set up those applications. So I'm just going to use the landing page for now. And this is how you design those event boards. It is a user interface for that, and we have all the you build it up completely through a drag and drop user interface. So different layout components. And I'm not going to go through all of them, but you can see there's charts, there's checkboxes, there's data selectors, there's file uploaders, grids, lists, sliders, spark lines, graphs, different kinds of charts and graphs. There are certain actions like hyperlinks that will take you around, and most importantly widgets. So I can make this, so if I take the whole area that you see here, I can actually turn this into a widget. I just save it, and now next time I can reuse this. Sorry, let me just go back to the blocks. I can reuse this as a widget. Now wiring this up to the page data and the underlying data, this is all handled through the data stream and the data stream connectors for the app. So the app can get its real-time information from that data stream. It can display it to you, and then you set up the logic or the way that you want to display this information with what you want, where, how. And again, we've got templates for different layouts, but you can also take components like this that you reuse a lot and make them into widgets. So that's kind of the 50,000 foot view of what XMPRO is, how we put this all together. And again, just to reiterate, it consists of 3 different components. I can get my 20 different systems that I look at, combine the data, get a logical flow of data going through it. So I can go from big data, all of these different systems, into smarter data, into the actions that I want. I can visualize it, but also behind this I can set up the rules to send emails, SMSs, notifications to systems like Teams, Slack, or whatever it is where you want these actions to be notified. I can then drill down into a recommendation and decide what action I want. This could automatically create an action into a back-end work order system for you, for example. But this is how we help you to detect and respond to critical events in real time without having to look at data or systems or 20 different things where the data could be. Thank you for your time. If you have any additional questions or would like to have more information, please contact us, and we'd happy to give you a more detailed presentation and demonstration.